Okay, today we are going to be focusing on simplifying radicals. First thing I want us to do on our paper, and if you have the paper we're working on in class, you can either do it right here in the middle or over to the right side over here. Either place works well, so in the middle or the side. You're going to copy a table we're going to make in our calculator. In our calculator, we're going to go to the y equals, and we're going to type in y equals x squared. Nice and simple. y1 equals x squared. y1 equals x squared. When we have the x squared in there, we're going to look at the table. In the right hand, or wherever I told you to on the paper, I'm going to do it on my right hand side. I'm going to draw this table out. So this is y equals x squared, and what we have in y1, we have x and x squared. This is what my table is going to be made of, and you're going to use, it's going to be quite a long table. We're going to go ahead and copy this entire table all the way down to 15, 16, maybe 20. So we're going to go 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, 5, 25, 6, 36, 7, 49, 8, 64, 9, 81, 10, 100, 11, 121, 12, 144, 13, 169, 14, 196, 15, 225, yeah, 225, 16, 256, 17, 289, 18, 324, and 19 is 361, and I'm just going to stop at 20. Oh, can't see all those. So I basically just have a list of all of my perfect squares, and that's what these over here are. All these numbers on the right side are perfect squares. I'm going to tell you right now, when you take your next 3 tests, because you're going to have a TEKS test, you're going to have a 6 weeks test, and you're going to have a final before Christmas, I would suggest using this. You can use it in multiple places. These are perfect squares right here. Okay, should be finished copying by now. If you're not finished copying, go ahead and pause it like I just did. Again, right here, these are all my perfect squares. These are my perfect squares, and we're going to use those in these examples. Let's start with the example of square root of 96. Now if you have the paper, it's number 1 on your paper, simplifying square roots. This is what we're going to do. We're going to use this table that we made, and we're going to find a number that goes into this. So the greatest common factor, or the greatest factor of 96. So we're going to look here. We're going to start right here. And this is where 96 falls. 96 falls between the perfect squares of 81 and 100. I can use a calculator. I can start testing these numbers. So 81. So I'm going to start looking at 96 divided by, and I have 81. It's a decimal. I don't want decimals. Let's do 64. 96 divided by 64. Not going to work either. It's another decimal. Let's try 49. 96 divided by 49. Doesn't work either. We have decimals. We don't want decimals. 96 divided by 36. Still doesn't work. And I can kind of look at some of these numbers and realize what will and won't work. I know 25 is not going to go in here. Let's try 16. That looks like it may work. Divided by 16. Ah, that's it. You see how we have a whole number here? That means 16 is our magic number. So below this, I'm going to write 16. And after my magic number, like 16 here, that was our number. and the number we used was 6. So we're going to, and that's not a square root, that's a check mark, sorry. So we're going to have 16 and 6. And we're going to multiply those together. That's going to get us a square root. So if I look at 16 times 6, what we have in here, 16 times 6 equals 96 like we have up here. So what I'm going to do throughout this problem, and you don't have to do this on all the problems, but I'm going to do it on this one to show you what's happening. We're actually going to get the decimal equivalent or estimate of this answer. So let's just look at the square root of 96. That gets us 9.7979. This is an estimate, so I'm not going to put the whole thing. 9.7979. Let's do this bottom one here, just to show us that we're on this right path. Square root of 16 times 6. 9.7979. 9.7979. Alright. The reason we chose 16 as the winner here is because it's a perfect square. It's the largest perfect square that 96 is divisible by. So I need 16 because I know the square root of 16 is 4. That's why we have this table. 16 to 4. Oh, I'm sorry. Before we do that, let's split this up. Square root of 16 times the square root of 6. I'm going to check that at the calculator just so you know that it's still the same thing. Square root of 16. And then when you do this one, you have to kind of arrow over to get rid of it. If not, the square root will continue. Times the square root of 6. And we get the same answer. 9.7979. Now what I'm going to do is, like I said, I'm going to use this 16. I know this square root of 16, this piece right here, square root of 16 is 4. So I can change that to 4. And I have the square root of 6. So at this point, I have my answer. This right here is my answer. And I'm going to check it to make sure it's equivalent like the other ones. I'm going to put 4 square root of 6 and hit enter. And I get 9.7979. Alright, so this is how we do it. We take the problem, the number under the radical, we try to find where it would fall here, and then we look at all the smaller ones, and we see which one is divisible. We discovered that 16 went into 96 6 times. It's a whole number, so that was our goal. So we took the 16 over, and then you took that 6 that it was divisible by, and we separated that 96. Basically, we took 96 and separated two pieces that multiplied together to get 96. One just happened to be a whole number. Then we separated that into two radicals, two square roots, and we knew one was a perfect square because we listed all our perfect squares. That's why we looked for 16 in here, and that became the 4. And that's how we simplify the radicals. Okay, we're moving on to number 2 on the paper. Number 2 is the square root of 216. Square root of 216. Come down here, find where 216 would fall. 216 would fall right about there. I know with just some mental math that 196 won't come in there, 169 doesn't go in there, 144 doesn't go in there, 121 doesn't go in there. You really don't have to start checking until you get to numbers that are about half. Because at half you can start bringing in multiply by 2. So 100, I know 100 doesn't go in. 100 times 2 is 200. That's too close. 81. 81's not going to work, but let's just check it just to make sure. 216 divided by 81. No, we got another decimal, so I'm going to X that one out. Let's try 64. 216 divided by 64. 337. Nope, sorry. Doesn't work, not a whole number. 216 divided by, what's next? 49. Doesn't work. 36. 216 divided by 36. That's it. 36 is what we want, and that's divisible by 6. So 36 times 6, watch, 36 times 6 is equal to my 216. So 36 and 6 are my numbers. 36 is my winner. It's my perfect square, so I'm going to start with that one. 36, and then we're multiplying it by 6. 36 times 6. and we're going to say that's my square root. Then I can separate this square root into two pieces. So I have square root of 36 times the square root of 6. And then I know that the square root of 36 is 6. So this just simplifies to 6. This is not, let me repeat, not the square root of 6. No, we're done with that. This 6 is not a perfect square, so we don't do anything with it. We just bring it down in 6. So that is my answer there. If I want to make sure I did this right, I can use my calculator. In my calculator, I can go the square root of 216, enter, and then right below it I can do 6 square root of 6 and hit enter, and both of those equal 14.6969. 14.6969. Since these are equivalent, we know we did that right. Okay, let's step this up. We're going to throw a little bit of a change into the process. Our next one is going to be number 12 from this paper. Number 12 is 9, the square root of 245. You'll notice that this one has a number in front of the radical. And what we know this is its multiplication. 9 times the square root of 245. We're going to take this 9 and we're just going to leave it alone until we finished working with the square root of 245. Square root of 245, let's go ahead and get our calculator out. 245 would fall somewhere around here in my list of perfect squares. Doesn't work. Gonna start closer to 100. Let's check 121. Does 121 work? No. 121 doesn't work. 100. Let's start with 81. Does 81 work? 245 divided by 81. Nope, that doesn't work. Let's try 64. 245 divided by, what would we say, 64? 64. Does that work? Nope, that's not a perfect square. Let's try 49. 245 divided by 49. And that's it. Sorry, I messed up the next there. So we have 5. So 49 times 5 gets me my 245. So 49 and 5 are my magic numbers. 49 is that winner, that's why it goes first, times 5. Then from here we're going to keep that 9 out in front. We're going to separate the 49 off, and then we're going to have multiply by square root of 5. So we have 9 times 49 times the square root of 5. 3 factors here. I know 49 is my special number, it's that winner. Square root of 49 is 7. So we have 9 times 7 times the square root of 5. Yet simple multiplication in the front now. 9 times 7, 63. Square root of 5. That is my answer. That's 9 the square root of 45, 245. Okay, a lot of times I get a question about what if we choose the wrong number over here. So we're actually going to go back and we're going to do number 1 again. We're going to do the square root of 96. We're actually going to do it over. But instead of doing the square root of 96 and finding the biggest perfect square that goes in there, which is 16, we're going to mess up and find the 4. So if I do 96 divided by 4, which is still a perfect square, I get 24. 24 times 4 is the 96 I was looking for. So we've done it right. Our magic number is 4, our winner, times 24. It should be right. We're doing it right, but it's not the largest one, so we're going to see what happens here. Separate that. Square root of 4 times square root of 24, which is 2 the square root of 24. If I plug that in the calculator, 2 square root of 24, I still get the 9.7979. And that still equals 9.7979. But this is too big. It's actually divisible by one of these. So what we're actually going to do is look and say, hey, 4 goes into this again. So we have 2 times, and inside here we're going to say 4 goes into that. 4 times 6. Separate that. 2 times the square root of 4 times the square root of 6. And you know the square root of 2, sorry, the square root of 4 is 2 times the square root of 6, and 2 times 2 is 4, so 4 to the square root of 6. That's my answer. So if you don't get the biggest one, it's okay. You're just going to have to kind of keep going and look and see if you can divide that radical in again. On a test that is multiple choice, if you get to this point and you don't find it, either you did it wrong or you need to keep going. So try to just keep going and see if another one of these goes in. Of course, it'll be that one or a smaller number usually. Alright, let's do one more new one. So let's pick number 15. Number 15 is 5, the square root of 180. Now, why don't y'all go ahead and try it, and then we'll check it. Hopefully you've had a chance to work this out. We're going to keep that 5 off to the side just like we did with the 9 over here, and we're going to expand out this 180. Let's see where the 180 falls. 180 falls somewhere around here. And I'm going to start about halfway through this, around 90, so let's start with 81. 81 doesn't go into it. 180 divided by, let's try 64. That doesn't work. 180 divided by 49. That doesn't work. 180 divided by 36. Oh, that works. So for 36, we have a 5. 5 times 36. That gets us our 180. So let's split up the 180. Our winner again was 36. And then we're going to multiply it by 5 in the parentheses. Let's go ahead and separate that. 5 times the square root of 36 times the square root of 5. 5 times 6 times the square root of 5. And then 5 times 6 is 30. And then the square root of 5. That's my answer there. Your assignment today is to finish this front and at least until 19. 20 and on are bonus.